Concept exam number 8, topics 11 through 15. This topic, what does f prime say about f? The graph of the derivative f prime of continuous function is shown. The two questions, on what intervals is f increasing and on what intervals is f decreasing, even though we're looking at f prime. We need to think this through a little bit. Shouldn't f be increasing when the slopes of the tangent lines are positive? And shouldn't f be decreasing when the slopes of the tangent lines are negative? Well, if we go along here, these are positive values on f prime, as are these, and these. Everything else is a negative value. Therefore, f is increasing from 0 to 1, again from 5 to 6, and finally from 7, it looks like it goes to out to infinity. It appears that this will continue. Decreasing is everywhere from 1 to 5, and from 6 to 7. And that's it. Any questions? Number 2, we need to differentiate the function. F of t equals 1/3 t to the 9th minus 7t cubed plus t. So f prime of t would be, let's see, 9 times a third is 3, t to the 8th minus 3 times 7 is 21, t squared plus the derivative of, which is prime of t is 1. I should do it for number 2. It's a pretty straightforward general differentiation of a polynomial. Any questions there? Okay, for number 3, I'm going to rewrite this function just a little bit. F of x is equal to 8x plus, instead of 9 over x, I'm going to write that as 9x to the negative 1. That'll just make it a little easier for me to find the derivative. The derivative of 8x is just 8. The derivative of 9x to the negative 1 should be negative 9. Negative 1 times 9 is negative 9. X to the negative 2. So I could write this as 8 minus 9x to the negative 2, or if I chose to, I could write it as 8 minus 9 over x squared. Either form will do. Any questions? Number 4, they ask us to differentiate quotient, so we'll go ahead and use the quotient rule. So the derivative here would equal the denominator squared, and we're going to keep that denominator then here, 2t squared minus 4t plus 5, we can square that, times the derivative of the numerator, which in this case would be 16t, minus, this time we'll keep the numerator, 8t squared, and multiply by the derivative of the denominator, which would be, what, 4t minus 4. And then we'll see if we can clean that up just a little bit. Let's see. I can take a 4 out of this. Let's just go ahead and do that rewrite right here. I can take a 4 out of this and write it as 4 times the quantity t minus 1. I can combine that 4 with the 8 if I chose to. Let's see, we have 16t times t, 2t squared, minus 4t plus 5, minus, here I have 32t squared times t minus 1, all over this 2t squared minus 4t plus 5, quantity squared. Let's factor out a 16 and a t, and see what's left here. I've got the 2t squared minus 4t plus 5. Here I've got a multiple of 2t times this t minus 1. Let's go ahead and work on that here in a little scratch. 2t times t minus 1 would be, let's see, watch out for the negative. Negative 2t squared, and then plus 2t all over this trinomial squared still. And inside, up in the top here, we can clean up a little bit. 16t times the quantity 2t squared minus 2t squared, those will zero out. And I've got negative 14, a positive 2t, that's a negative 2t and a positive 5. So what I could see in here is a 5 minus 2t, and I still have that trinomial squared, 2t squared minus 4t plus 5. So it's not a thing of beauty, but it is a derivative. Any questions here? For 5, we're asked to find an equation of the tangent line to the given curve at the specified point. So I've got a point, all I need is a slope. So let's go ahead and find the derivatives to help us with the slope here. See, this is a product. I've got e to the x times the cosine x function, so I'll keep the e to the x multiplied by the derivative of cosine, which is negative sine x, plus this time we'll keep the cosine x and multiply by the derivative of e to the x, which is e to the x. Let's clean that up a hair. I can take out an e to the x, and if I factor, I've got cosine x minus sine x would be the simplest way to write that. Let's evaluate that when x is 0. So y prime at 0 gives me e to the 0 times cosine of 0 minus sine of 0. Well, e to the 0 is 1. Cosine of 0 is also 1, and sine of 0 is 0, so this whole thing evaluates to 1. I've got a slope of 1 and a y-intercept of 1, so my equation is y equals 1x plus 1, equation of the tangent line at the point 0, 1. Any questions here? Okay, these last two questions deal with the chain rule. On number 6, I'm trying to find the derivative of f. It's a function to the power of 4. So the derivative of f, the power of 4, we'll deal with 7x squared minus x plus 6, reduce the power by 1. And then go ahead and multiply by the derivative of this inside function, which would be 14x minus 1. There's not a lot we can do with that, so let's just leave it where it is. Number 7, we've got quite a bit more complex thing going on here because we've got composite functions multiplied by each other, so I've got to deal with a product rule and also the chain rule along the way. So let's see if we can make this fit in the space allowed here. H prime of t would equal, let's keep this first function the way it is, the 8th minus 1 to the 7th power, times the derivative of the second function, which would be 8 times t to the 7th plus 1, and reduce the power by 1. But also, don't forget, we have to follow the chain here and multiply by the derivative of the inner function, which would be 7t to the 6th plus, now we keep the second function, leave it alone, multiply by the derivative of the first, so that would be times the 7 to the 8 minus 1 all to the 6th, but don't forget to follow the chain and multiply by the inside function's derivative, which would be 8t to the 7th. Alright, let's see what we have here. H prime of t is equal to 8 times 7t to the 6th is 56t to the 6th. I have a t to the 8th minus 1 to the 7th, and I have a t to the 7th plus 1 to the 7th. Plus, I have 7 times 8 is 56t to the 7th. I have a t to the 8th minus 1 to the 6th, and I have a t to the 7th plus 1 to the 8th. There's some common factors here. The 56th is common. There's some values of t that are common here, t to the 6th and t to the 7th. I've got a t to the 8 minus 1 is common, and a t to the 7 plus 1 is common. So everything has a common factor somewhere in here. So let's see if we can pull out all those common factors and make this look a little simpler. So let's see, 56 is common, t to the 6th, t to the 7th. I can take out a t to the 6th. T to the 8th minus 1. I have a 7th power and a 6th power. I should be able to take the 6th power out. And t to the 7th plus 1. I have a 7th power and an 8th power. I should be able to take the 7th power out. Let's see what's left when we do that. Let's see, there's nothing here. There is a t to the 8th minus 1 left here. All of the t to the 7th plus 1 were taken out. Plus, here I have a remaining t, because I only took out 56t to the 6th. let's see, t to the 8th minus 1 to the 6th, I took all of those, but there is a t to the 7th plus 1 left, because I only took out 7 of those. Just focusing on this chunk right here, since I'm going to run out of space, let's clean that up here. I've got t to the 8th minus 1 plus, if I take t times t to the 7th, that's another t to the 8th, plus t times 1 is t. So that looks like 2t to the 8th plus t minus 1 is what's inside that bracket. So let's go ahead and write that final answer. H prime of t is equal to 56 t to the 6th times the quantity t to the 8th minus 1 all to the 6th power times the quantity t to the 7th plus 1 all to the 7th power times the quantity we cleaned up here 2t to the 8th plus t minus 1, and we're done. Any questions on anything we can still see here on the screen?